Hello, everybody. Welcome to 4.1, relationships between two categorical variables. This whole unit's going to be about bivariate data, which is two variable data, right? Bivariate, two variables. So we're going to start with categorical, and then later on we'll get to quantitative variables. And yeah, so with two variables, there's two types. There's response variable and explanatory variable. Now, response variable, response variable measures an outcome of a study where looks terrible, but it's all right. Where explanatory variable may help predict or explain changes in a response variable. Ooh. Okay. So basically the explanatory variable is like your X variable, typically your input variable, your independent variable, X slash input slash independent. And the response variable is essentially like the Y or the output or the dependent variable. So the explanatory variable will be one that is kind of a baseline that you use to try to predict the response variable. The response variable responds to the explanatory. It's an output. It's dependent upon the explanatory. So we'll look at examples of that coming up. So with categorical variables specifically, there are a couple ways to present them or chart them. So one of them is a segmented bar chart, which we're going to make in this video. Segmented bar chart displays the possible values of a categorical variable as segments of a rectangle, which is just a bar basically. So basically just imagine a bar that's broken up into different sections, and that's what we're going to make. With the area of each segment proportional to the percent of individuals in the corresponding category. So like again, we'll see what to do. So you'll see an example of that coming up. A two-way table, or the table of frequencies or relative frequencies. That summarizes the relationship between two categorical variables. Or some group of individuals. So again, we will also see a two-way table later on. So you'll get to see what those things are, more than just the definitions. So our first example, we have identify the explanatory variable for the following relationships, explain your reasoning. So the first one we have is age of students and whether they allow to stay up past 11 p.m. on a school night. The age of students is going to be our explanatory variable here. I'll explain why in a second. And then whether they are allowed to stay up past 11 p.m. on a school night is your response variable. And so that's because the age of students can be used to help predict whether they're allowed to stay up past 11, right? So if I know a student's younger, I could probably predict that they won't be allowed to stay up past 11. But if a student is older, I can predict that maybe they are allowed to stay up past 11. So age of students, age can predict whether or not they stay up late. Now, the next one's kind of a trick question. The average hours of study time per week and the average hours of extracurricular activities per week. Both of them are kind of the same variable. They're both time related. They're both hours of something. So technically speaking, they could both be the explanatory variable and be used to predict the other. So this one's kind of a weird one. Either one can be explanatory slash response. Like it can go either way. One can be the explanatory while the other is response, or vice versa. Each one can be used to predict the other. Next one. So this is a two-way table. If you're wondering what a two-way table was, here you go. So a two-way table has the two types of variables. You have the explanatory variable typically across the top, and you have the response variable typically along the side. And then the variations of the variable are detailed in there. So we have female and male, and we have yes and no for like the allergies there. So yeah, allergies or no, they don't have allergies. So the two variables, and then obviously the different variations of those variables. So that's a two-way table. You can see we have it broken down. It's pretty easy to read. You got the totals on both sides here. Now, typically the totals that'll matter more are going to be the bottom ones, and you're going to see why in a second, because we're going to make a segmented bar chart with this data. So to make a segmented bar chart, so we were talking about that as well earlier. Let's go ahead and show you one. So we're going to have the explanatory variable at the bottom, which is, of course, our male and female. And then on the side, though, is going to be our percentages. We're going to go all the way up to 100%. So let me try to break this down pretty evenly. So this will be 50. All right, let's see here. 40, 30, 20, 10. Try to make this kind of okay. 60, 70, 80, 90. All right, percentages. And we're going to have these two bars, one for male, one for female. I'm going to try to make them straight as I can, but I'm not a magician, so I don't know. Okay, I'll do my best though. There's male. It's hard because my elbow is like resting on the table here, and then I pick it up, and then it goes squirrely. Well, that was terrible. It's just not going to be perfect. Just bear with me here. Drawing a straight line is kind of tough when it's a vertical screen because my computer's standing up, but it's not laying down, so that makes it harder. All right. So we're going to, as we said in the definition, we're going to break up the bars into the certain percentages. So what we have to do is we're going to have to find the percentages of female that have allergies and percentage of females that don't have allergies, and we'll break that up to a certain region, whatever percentage has it, and whichever percentage doesn't. And then we're going to do the same thing with male. So let's start with the female one. Let's do female with green. Why not? So female, we have 50 females out of 130 females, right? 50 females out of a total of 130 that have allergies. So this comes out as a percentage to about 38%. And then for females, we also have 80 out of 130, which comes out to 62%. So that's all the females, right? 100% of the females. So we're going to break the female bar up into this. So we're going to have, let's choose red for yes. We're going to have 38%. So we're going to have to look at where 38% is, right? It's right under 40. So it's going to be, this is a hard graph to use, but 38% probably about there. And we're going to shape this all in for essentially the yes part. So let me make a little key here. Red is for yes. Let's go back. Let's make a purple one. Purple can be for no. So the remaining 62% of this bar is all the no's. So we're going to fill this in purple. And there's essentially, half of my segmented bar graph. We got to do males still, but you see the idea. We have 38% here shaded in red for yes, and then 62% shaded in no for, or shaded in purple for no. That makes the 100% for female. So now we're going to do the same thing with male. So let's go to, I don't know what color to use. Let's just stick with the green for this. So for males, we have 34 out of 97 that had yes. 34 out of 97 is about 35%. And then we had 63 out of 97, which is about 65%. And so we're going to do the same thing. We're going to color these in. So red is going to be for yeses again. So we're going to go up to 35%, which is about here. So just a little lower than the female bar graphs had. And then the remaining 65% was all no. So we're going to shade that in purple. So very similar between the two. But there you go. So you have to find the percentages first, and then those percentages are going to be what fills up the bars, right? Because the bars are always going to be based on the percentages here. And it says that back in our statement here, how each area segment is proportional to the percent, right? So you're going to have to find the percent of each category so that you can fill those percentages into the bars. All right, and then finally, the backside of this association. All right, there is an association between two variables if knowing the value of one variable helps us predict the value of the other. If knowing the value of one does not help us predict the value of the other, then there is no association between the variables. So basically, if we know one of the variables and we can predict what happens to it, then there must be some association, right? But if we can't, then that probably tells us that there's not an association. So we have a segmented bar graph here, segmented bar graph, segmented bar chart, whatever you want to call it. And it looks a little bit better than ours, right? Because it's obviously neater. But you can see the percentages again here. You got the explanatory variable, which is the class of travel, and you've got the response variable, which is survival status. So we're trying to determine if there's an association between survival status and class of travel. Again, at the bottom here is your explanatory variable. Just going to go ahead and label that for fun. And then this one is the response variable. Okay, just labeling it for fun. Explain your reasoning, right? And if there is an association, briefly describe it. So answer here is yes, there is an association. You can tell because the bars are different. There is an association between class of travel and survival status. The higher class folks survived more than the lower class folks. So knowing which class of travel they were, we can predict their survival status, if they are likely to live or likely to have died. So we're going to simply write this all out in a nice clean statement because this is statistics and we have to explain work. So here we go. So there is an association between survival status and class of travel, right? So notice I'm making that claim right away. Like there is an association. So I'm answering the question right away. And now I'm going to explain my reasoning here. Oh, well, first off, yeah, no, I got that. Because the survival rates were not the same for the different classes of travel. Right? So again, what I'm saying is there is an association because the survival rates are different between the classes of travel, right? That's basically what I've just said. But now I'm going to describe the association. So passengers in first class were the most likely to survive. A little bit of lag on my computer there, survive. While passengers in third class are most likely or least likely to survive. I guess would be phrasing it better. Because otherwise it kind of sounds harsh, or least likely to survive. There you go. And again, I know it doesn't handwriting's tough because again, I bear with me here because again, you're not writing what I'm writing. I'm on a computer screen, it's standing upwards, it's not laying down. I'm gonna make up all the excuses I feel like I have to write. So anyway, that's it for 4.1, guys. I'll see you in 4.2. Bye for now.